Session we have seen about the schematic diagram of this grinding machine. Now in this session we have to learn that how the various machine tools are correlated with each other. So look at this table. This table give idea about the student that how various machine tools like lathe, milling, shaper, drilling and grinding can be correlated with each other in terms of relative motion between the tool, workpiece and what kind of surfaces we are using to remove the excess material. So previously we have discussed that in the lathe, workpiece is basically rotating and the tool is here a single point cutting tool which is stationary and the surface is circular. So circular type of surfaces are preferred to remove the excess material from the lathe. Same way in the milling we have the workpiece is the stationary and we are preferring the flat surface and the tool is rotating and the tool is multi-point cutting tool. Same way we have the shaper machine. The shaper machine is preferred for the flat surfaces. Here once again we have the workpiece is in the stationary and the tool is basically reciprocating if we are using the quick return mechanism and that tool is in the form of single point cutting tool. Same way we can able to understand the drilling with respect to workpiece too and what kind of surfaces are there. So by considering this analogy, in the grinding machine we are going to remove the very small amount of material, but here we might be have workpiece is stationary, we might have the workpiece might be a reciprocating, we might have the workpiece is rotating. The reason is there grinding is the last operation which is being performed on the workpiece, means after the performing the grinding operation generally that component is basically going for the either assembly or further another finishing operations. No further machining process will carried out after this grinding operation. And as discussed that tool is in form of this abrasive wheel. So we are going to remove the very small amount of material so that whatever the final surface finish we are achieve that is very good and that we can directly apply uh, to our end use. Here that one point we must have to understand that here we can either use the flat or circular, any kind of surfaces are there we can use this grinding machine, but we might be have the different grinding machinings for that purpose. Now let us look at the application area of the grinding machine. Based on the amount of material to be removed, the generally rough grinding and precision grinding are the two basic categories through in which grinding machines are used. In the rough grinding, we are removing the very small amount of material, but that amount of material is unknown. That rough grinding is applied generally in the casting or welding parts. As the casting to remove the excess material like gate, runner, riser, we are using the rough grinding. Same way, once the welded part is being prepared to make the to remove the excess material of the weld bead, we are doing the grinding. Same way precision grinding can be applied for the final component dimensions, means final components whose dimensions are achieved in the tolerance. So to get the required tolerances of the dimension we go for the grinding machines where we are removing the very small amount of material. So shaft, bearing, gears are the general parts where we are preferring the precision grinding operations, right? So in this session we have seen about the introduction about the grinding machine, what is the grinding machine, how the analogy of the grinding machine is basically applied, and lastly we have seen the application area of the grinding machine. Thank you.